Hi everyone, this is Hinky Lee from the Department of Chemical Engineering. Today I would like to share with you my recent research topic, which is related to the implantable drug deliverable system by using a really pioneer hydrogel called Smart Stimuli Responsive Hydrogel. So we will use this to treat the cancer treatment. To begin, I'll give you a brief introduction or background of what this project is about and what's the specific points and novelty for this project. And followed by, we'll go through a few experimental sections with some results. Current results will be disclosed as well. And I will close the presentation with a short summary. So firstly, we're using this kind of stimuli responsive hydrogel as our target analyte. So actually, what is this stimuli responsive means? So actually, stimuli responsive means for a particular hydrogel, when there are stimuli trigger or trigger point, we can trigger the change of this kind of hydrogel. It may cause to some physical chemical changes like this one. For example, this one will be collapsed due to thermal responsive trigger. So there's actually different kinds of stimuli can be chosen for particular usage of your studies. For example, pH or electricity, magnetic, or even glucose. So they can responsive for the trigger of this kind of particular hydrogel. So in a project, we will compose of these hydrogels, stimuli responsive hydrogel, and we will confine this kind of iron oxide inside for energy conversion purpose. On the other hand, we will separately fabricate this kind of super tiny implantable drug delivery system or device. So how this mechanism works. So you can see after fabrication of this implantable device, the drug will be loaded into these parts, the upper part for this device, and on the below part, you can see for this really tiny narrow channel, will soak or cure with these hybrid nanoparticle hydrogel composite onto this channel. So one of the main characteristics for this channel is while the temperature goes beyond these LCST, aka the lowest critical solution temperature, they would change their physical form from swollen form onto this collapsed form. So in other words, they will collapse. So once they collapse, the drug from above can pass through this path. So to get out from this outlet, to get into the human brain tumor site. So the ultimate goal for this one, we have to apply this one and inject or implant into the human brain, you can see, by this kind of particular device. Once it coordinates the tumor's position, so they could implant into it and to leave this device onto the human brain, and they can be ejected like this. So what's the novelty and the highlight for this project? It's the non-invasive penetration with drug control system, as well as we are now applying this kind of stimuli responsive drug releasing system in a kind of controllable way. So you can see this kind of mechanism, we can treat it as an on-off drug control switch. So here is the project introduction about what my project is ongoing and what this project is about. So let's move on to materials part. So actually this material are composed of, just as I mentioned, nanoparticle as well as the nanogel, the hydrogel in nano form. So first of all, we synthesize these nanoparticles by this precipitation method. So after we synthesize this one, we characterize with various of characterization methods, which I will not go into details. Also, we separately synthesize with this nanogel, with this monomer initiator. This really critical one. It's this Ni pump is a really authentic, typical for the thermal responsive hydrogel. So it's kind of the top representative for in this field. So you can see we've synthesized with this nanogel and characterized as well. And afterwards, we characterize with this one. And as I've mentioned, the LCST is a really important parameter in our research. So this temperature, how can we determine it? Is by different kind of methods. For example, by this turbidity test by DSC or by DLS. All are okay for characterizing this kind of properties. So finally, we would like to synthesize our outmode component, which is this hybrid nanoparticle and nanogel composite. So you can see, first of all, actually we synthesize with these nanogel with this hydrogel network, 3D networks, and we can intrinsically add with this kind of nanogel to make them being confined inside this kind of networks here. So you can see from TM data figures, this the outside, this kind of shell, it's the Ni pump nanogel, and they are like the nanoparticles are actually encapsulated inside this one. So we can like confirm by XRD as well as the FTIR. And finally, this thermal conversion efficiency will calculate in future time. So this is the experiment which we plan to do. And for the device part, actually for the device part is, the device is composed of two layers, the top layers and the bottom layer. And the bottom layer and the top layer, while they have aligned to be a one single layer here, you can see. So we have the inlet part here and the outlet part here. So the drug will be injected into from this part, and the drug will be released from this outlet part. So how can we implement the nanogel, or how can we supply this nanogel onto the device? There's a various kinds of methods here shown here, but it's too detailed and I will not go into detail, just show you maybe it can be put into this porous membrane, or they can be done by this hydrogen patterning or outlet modification by this coating for this kind of membrane inside on top of this kind of outlets. So finally, how can we trigger the drug the release or the collapse for this P9I pump nanogel? But we will use this kind of LED system. So the LED, you can see, while this device plays onto this device, this platform, so this LED from the bottom will shine lights here, and the iron oxide nanoparticle will absorb the heat, the light energy, and it will convert into the light energy, the heat energy, so which will heat up the nanogel, so the nanogel will collapse, so the drug can release like that. So we will do this drug loading as well, and drug release detection as well. So yeah, this is almost the end of my presentation. So thank you so much for listening. Hope this project will be succeed. Thank you so much.